All right, so your project was graded finally. I know it took a while, so thank you for the patience. So yeah, so your grades are up for that. So if you didn't check your grade yet, obviously you're gonna want to check that. Another thing too for the grades, I have like a rubric that I used for the grading. So I have comments kind of section by section in that rubric. So uh, take a look at that. And I also have comments that are directly on the PDF itself. So if you look at your PDF that you submitted, you should see some comments that I have that are kind of annotated on there now. So check that out and make sure you look at all the feedback so you can take that or keep that in mind for the second project. So the average grade for the project was 69.14%, and the high was 100%. So one person got 100, so good job to them. We had 17 A's, so there was quite a lot of A's. Basically, you most likely got an A if you did the entire project and did all of your write-ups. And then, so there's 17 A's, 3 B's, 2 C's, 6 D's, and then, unfortunately, 11 F's. So for the F's, basically that occurred if you didn't submit the project. There was a few students that didn't submit anything at all. And then a few students only did, only 1 or 2 sections, and that was it. So I don't know if that was just a time management thing or if you were just really struggling to understand the concepts. But if you are struggling to understand the concepts, then make sure that you reach out to me in a Discord or something like that. Okay, so that's the grade breakdown for the project, and then currently, as the grades currently stand for the entire class, the average is a 75.2%. So that's a pretty reasonable average, really. Obviously, I'd like it to be a little bit higher, but that's a reasonable average. So if we were going to end the semester right now, as the grades currently stand, I wouldn't be doing any curving, most likely. So if the grades do go up, though, with the second project and the other few quizzes that I have to grade, then, obviously I'm not going to change anything. I'll leave it like that. So let's say that the average grade went up by 2% or something, I'm going to keep that. But if all of you do horrifically, which I don't hope that happens, of course, but if everyone is terrible on the second project and the average goes down a lot, then I would apply a curve. But I don't think that's going to be likely. I think, well, I'm currently guessing that you guys will do well in the second project. So I know there's some, I don't know, anxiety going around about the second project, but hopefully we can alleviate some of those concerns today, and also, in the coming, I don't know, 2 weeks or whatever that we have to work on the project. This project mocks me. Okay, well, maybe it won't mock you in the days to come. I don't know. The homework should help. Really should help. Also, I'm going to drop your lowest quiz, so that's going to help the grades as well. So some of you haven't been able to make every single quiz, or maybe just did bad on one. So I'm going to have Canvas automatically drop the lowest quiz, so that'll help your grade out as well. What, the project, is that the same as the homework but bigger? The project is, similar for the homework with coding techniques, but, there's some different stuff too. Okay, and then also SOQs. I forgot to mention this last time, but SOQs are up. So that's the Student Opinion Questionnaire. So you can find that either in your email. I think they've been like berating you every single time you log in or something. So you can fill out the SOQ. You can get it either from your email or you can get it on your student portal. You should see it on the homepage there. So I'm pretty sure the SOQs are due by this Friday. So make sure that you fill that out and, of course, have honest feedback. That's going to help me out, especially if I teach this specific class again later on. And they are anonymous, of course, so I have no idea who says what. So you can be completely honest, and that'll be good. Okay, so I have a question. Would dropping a lowest quiz hurt me a little bit? So if I drop a quiz, it's not going to hurt you at all. If it does for whatever reason, then I won't drop the quiz in that case. But no, it's not going to affect your grade in a negative way. Okay, so that's the kind of, I don't know, recap so far for the class as a whole. So you guys are doing pretty well so far.
No sé qué cabe sacarla. No guardar las cosas.
No question or question?
Sí. Tú no lo has subido. Lo tengo. Mira. Ya está. Mira. El de tu arte de
Victor, you know your mic is on? Okay. Okay, there's a question, is there going to be any extra credit? No, there's not going to be any extra credit because you guys are doing pretty well so far, so no extra credit. Okay, any other questions for the class? Oh yeah, actually I also want to touch on too for the project. If you did poorly, that was either most likely one, you didn't complete every single section for the project, or you didn't do all of your write-ups. So the write-ups, they're a big part of your grade for the project. So make sure that you do the write-ups. And I had an example for the write-ups on the deliverables handout. So I don't know, use that as a reference if you struggled with the write-ups for the first project. Or if you have any questions, you can of course ask me in the Discord too. Or I can even, I'm not going to grade it, but I can quickly look over your project before you submit it too. And if you're missing something, then I can tell you. Obviously, you should do all that work yourself first, but if you want me to give you some, general feedback, I can do that before you submit your projects. All right, if there's no other questions, then we're going to get started. Okay, big question. This last homework was very challenging. I know that myself and many other fellow students have a lot of stress and anxiety about this upcoming project, perhaps more so than some of the other classes we're taking. I'm not sure what's possible at this point, but if we perhaps, if we can perhaps have an exam in lieu, if we can have an exam in lieu of the exam, I think project, or at least simplify the project in some way. So I'll get an idea of how hard you guys actually think the project really is when you actually start doing it. Because again, the coding for the project is going to be pretty similar to the homework. So now that you got the homework out of the way, which I know a lot of you guys didn't like the homework, that's not intentional. But once now that you have this homework out of the way, that should help with the project. But yeah, I don't want to kill you guys for the project, so I'm gonna, of course, always be in the Discord so I can kind of gauge how you guys are doing. I'm gonna keep the project as it is. That's the current plan. But if you need some help, I'll make some videos or something like that to help out. Yeah, that's a good. Yeah, I want to, of course, always gauge what you guys are thinking. So, be honest. Okay, you can use a review of addressing salaries. Yeah, so that'll be part of what we're doing today for the homework. We're going to be going over the homework. Pretty much, that's the only thing I really have planned for today. And then if we have some more time too, we can kind of have an open forum or something for any questions for the second project. So we'll go over the homework, and then I'm going to go over a few things for the second project again to kind of reiterate it for the deliverables, and then we'll kind of have that open forum. Okay, so before we do that, we're going to go over the homework though. All right. Tell me too if my screen is laggy. Like, I don't know if that was in this class or another class, but one time Zoom was really laggy for the screen recording. So if it ever is, then make sure to tell me. Okay, so at the homework now, basically what I have on my screen here is just the starter code for MATLAB that I gave you guys. And your project currently does not have any starter code I'm gonna leave it like that. So basically, starter code, it can be somewhat helpful. Kind of like this homework, but I've personally found, for one of my classes, while starter code can be good, it also kind of boxes you into whoever wrote the starter code to their kind of style of coding. And like you could have done this homework in a different way too for some of these things, but I know sometimes you guys got stuck on one line of code, especially this line of code here, because you see my starter code and you're kind of boxed into that methodology that I have here when you really could have done it in a different way yourself. So, however, with that said, even though I don't have starter code, and we'll talk about this a bit later too, on the deliverables, I have this section for a recommended attack plan, and I really encourage you to look at this because this attack plan is basically, we kind of have two sections for the project. We have a section for cases and deaths, which is what you had in the first project for counties. And then the other section that we have is for hospitalization data. And the coding that you do for both of those sections is similar. So it's very similar to what I have in this section for the hospitalization. So while there are, of course, different data, a lot of the techniques that you use are the same. So if you look through all of this, it's pretty in depth for what you have to do. So I would really recommend to take a look at this. Okay, so for the homework. First thing that we had to do, actually first I'll run my code just so you see what should come up in the end. I know the data that we have, it's a ton of data, so the code kind of takes a little bit to run. So this is the graph that you should have in the end. Okay. No one's been... Yeah, okay, never mind. I was making sure that my headphones were working, but yeah, I heard one of you before. Okay, so this is the graph that you should have in the end. So this is the rate for all of these players here for how often they hit a ball over 100 miles per hour. And we had one parameter in the code for all of these players. They need to have a amount of plate appearances that are over 100, or sorry, over 500. So if they had less than 500 plate appearances, then we took them out. Okay, so this is the graph that you should have had in the end. So if you got to this point, if you're actually able to make the graph, then good job. Okay, so let's go back here. And I'll just, actually I'll copy and paste this. All right, I'm gonna put this over here. Okay, so the first thing we had was importing the data. Oh, another thing, as I'm doing this in front of you, I know it's going to seem a little contradictory, but for the project, a lot of you commented out your entire code when you submitted it, which don't do that. I need to be able to run the code right away when I download your code. That's kind of one of the marks that I did for the grading. I graded that pretty lightly this time around. I don't even think I actually docked any points for that. But one of the parameters for the grading for this project, for the second project, I want to be able to take your code and automatically run it and not have to change anything on the code, and all of your graphs should come up. So make sure that you're not commenting out the entire code this time. So I'm doing this right now just to kind of go section by section here with you. Okay, so the first thing we had in the starter code that was already there was importing all of the data that we had. So we have 3 spreadsheets here for 2020, 2019, and 2018. So all of these spreadsheets, they have the same amount of columns in them. But of course, the amount of rows are different just because there's more or less plate appearances for each year. So if you open up this spreadsheet, we have like 89. Yeah, we have 89 columns, an insane amount. And we have each basically kind of event for each player. So it shows basically every single time that something happens or doesn't happen. So you'll see in column 9 for events, when it says null, basically nothing happened that was kind of in play. Okay, so we have those 3 spreadsheets, and then the first thing that we'll do is append them so we can kind of put them into one spreadsheet. So I'll just comment this out. Okay, and if we run this, then we get one spreadsheet now that we called Angel. So all we did there was append the 3 spreadsheets to each other. So we have just one gigantic spreadsheet now. Okay, next thing we're going to do some bookkeeping here. So that's a section called bookkeeping. First thing we're going to do is convert some things as needed. So let's actually comment out a few more of these. Okay, so the first thing we did is we converted the player names to a string. So let's take a look at what they look like right now. Kind of make this smaller here. Okay, so if we go to the spreadsheet, the first thing that we see when we go to player name is we have single quotes around each player name. So if I go in the command window, let's bring this up a bit, and I type in class of angels.playerName, and then we see that it's a cell. So as it currently stands, we have a cell, so it's actually basically a character array for all of these names. So it's only showing each letter for the player. So it's not, if I was going to reference one of these rows, it would just be a character array instead of a string, instead of a string. So we want it to be a string so I can reference one of these rows and get the entire name and not just letter by letter. Okay, there's a question for the project. If we use a figure visible off code, would we get points taken off if you have to change it to on? No, you can leave it like that. In fact, yeah, I recommend you to use the visible command that Karen's talking about. I don't care if it's either off or on, because if it's first off, that's totally fine. Because then I can run your code and I can just see if there's any errors or not, and then I can easily change how I'm grading them. I can easily change all of your figures to be on just with one little command. And then I can check it that way. Okay, so the player names, where was I? So yeah, we just wanted to convert it to a string just so I can reference that entire name and not just one character. Okay, the next thing, we're also converting the launch speed, which is the main kind of parameter of this homework, I guess. We're going to convert that to a double. So let's see what that class is right now. So if I type in class angels.launchSpeed, right now that's also a cell. So we want to have a number for that. So launch speed, I don't remember which column that was in. I'm not going to look for it too long, but here it is. Column 54. So we want that to be a number, right? So we're going to convert that into a double. So a double, kind of simplifying it, is just going to be a number for us. So we use our command string to double. Even though this was a cell, we can still use this command or function string to double to convert that to a number. Next thing, we also convert our events to a string. So the events, that's also going to be one of the columns that we're looking at a lot here. So if we type in class angels.events, that's also a cell, so we want to convert that to a string. Okay, so that's just some simple bookkeeping that we did just to kind of get that out of the way. And then if I run our script again, you'll see that this should update now. Yep, and now you see that they're just numbers, and we no longer have those quotations. And then if we go to player name, then we see double quotes around the player name, so that means that it's a string. Okay, the next thing we did was we got the unique player names. So as it currently stands, we have 57,784 rows. And in each of those rows, we have some player name. So obviously, you know, they're repeated quite a lot here, but we want to restrict this to only the unique players that we actually have on the team. So to do that, we just have to use our unique function. And when we run that, I didn't have to. But once we run that, we're going to get the unique players that we have. So I think that was 61 players. Okay, and if we open this up, then we see all of the unique players that we have. Okay, next thing we do is convert the years to a date vec. So all of this so far is stuff that I gave you directly in the starter code. So I'll comment a few more of this out. Okay, so first thing we do is convert our years to a date vec. So if I go to our main spreadsheet here, we'll see in column 2 we have game date. So I want to kind of break this down year by year. So I want to look at each year that we have. So to do that, I need to first make a date vec. So that's for my code called years dv. And that just breaks it down again into a date vec. So it goes by year, month, day, and then hour, minutes, seconds. All right, so we have that. And then the next thing is we're going to just get the unique year. So obviously we could have done this part manually, of course, but we also want to practice a good coding technique. So imagine if we had some data set that had a lot of years, it would kind of suck to do it manually. So we want to use coding. Okay, so to get the unique years, we're just going to use our unique function once again. And we're only going to look at the first column here in this date vec array. So we just want to look at this first column. And once we do that, then we see that our unique years are 2018, 2019, and 2020. Okay, so pretty simple so far, I know. But now we're actually going to get into the, I guess we're starting to get into the meat of the homework. Okay, so I think the main thing that really tripped up a lot of people for this homework was, of course, for loops, but really using for loops with cell arrays. So I know that using cell arrays can be kind of a little tricky to keep everything kind of on, I don't know, keep track of everything really. Because you have a cell array, and then within those cell arrays, you have arrays in each of those cells. So it can get kind of hard to keep track of. So, but I recommend to use cell arrays because they also keep everything neater and easier for us to reference. And we'll kind of go over that too. Okay, so I'm going to have my actual code over here on the left just so we can go over this, for sure correctly. Okay, so the first thing we're going to do is find the indices for each player. So we have 61 players, and I want to find the indices for each player that's in our main spreadsheet that I called angels. I know what to guess I can. Let me rearrange some of this stuff here. Okay, and then I'll move this over like that. Okay, so again, first thing we want to do, we want to find the indices for all of our players in our main spreadsheet that's over here on the left. So player name, that's column 6. So I want to find all the indices, for example, for Shohei Ohtani. So off the bat here, just looking at it, I know I should see he's in rows 1 to 3. I don't know, let's keep scrolling down. Oh, there he is again. I just lost him. Who cares? You get it. So we want to find all of the indices for each player. So doing this manually would just not work out. We have 57,000 rows plus. So we want to find this automatically with some code. So I'm going to use a cell array so I can have a cell for each player. And in this case, we're also using a cell array because the length for these individual arrays are going to be different. So we'll see what that looks like in just a second. Okay, so we're using a cell array. So because of that, we're using these curly braces here. So currently, as I have this, I'm going to have just one row. So that's why I have a colon here. MATLAB will just, it'll kind of do this automatically where it only needs one row. So that's why I have a colon. And we're going to do it for I amount of players. So that'll be for our 61 players. So the first thing we have to do for I equals 1. And then we're going to do length of players. And that'll be a length of 61. So we have 61 players. So that's why we're doing from 1 to the length of players. Okay, now to get these indices, we're going to use our find function that we've been using quite a lot now. So we'll do find, and that'll give us the rows for the indices for each player. Now we have to do a string compare. You could also use isMember, but in this case, string compare would be a better idea because remember from past lectures, I said that string compare is faster. Now usually this difference is negligible in speed, but it actually might make a difference in this code. I haven't actually tested the time. But because we have a very large data set, we can use string compare, which remember compares one string at a time. So we need to have just one string that we're comparing each time. While for isMember, we could use an entire array if we wanted to. But we're going one at a time here for each player, so we can use string compare. So for our first argument for string compare, we put kind of our reference, what we're looking at. So in our case, that'll be angels.playerName. So that's our main spreadsheet here. And then .playerName, column 6. Okay, so that's what we're looking at. And we want to find the indices for each player. So the second argument is going to be each player that we have. So for that, I'm going to move this over. I'm going to put players of I. And then make sure we balance out the parentheses. Okay, so as we currently have this, let's comment some of these out. Again, I'm going to go just kind of line by line here. So we're going to find the indices for each player. So to do that, we're using find and then string compare. So we're comparing each player that we have. We're iterating for I. So I can go player by player. And then we're going to find their respective indices. So let's run this right now. Take a moment. Oops, I put players somewhere here. That should be player. Okay, let's run it again. All right, there we go. And then if I click on player IND for indices, then we see that we have all of the indices for all of our players now. So, I said this a little bit earlier, but we're using a cell array here for a lot of reasons, but one of the main reasons is all of these arrays that we have inside of this cell array, they are different lengths. So we see for our first player, we have 4,500 rows. For the second player, we have 3,800. For the third player, we only have 31. So you see that they're all different. And if we were going to try to put this in just one array, we can't do that because each column has to be the same length. So let's first look at our player array. So we see the first player is Albert Pujols. So let's just kind of check our work, make sure that our code is working correctly so far. Okay, so the first player is Albert Pujols. So if I click on his cell, he's the first player, so he shows up right here. We see that his first index is row 128, and that's for our main spreadsheet. Okay, I'll get to your question in a second there. So first I want to go over this, and then I'll take a look at your question. Okay, so Albert Pujols is first time that he shows up in the spreadsheet is on row 128. So let's make sure that's actually correct. I scroll down and I go to row 128. Then I see that we have Albert Pujols, and we also have row 129, which we also saw here. So it's looking good. Okay, let me look at your question. Okay, Kevin, what does I and players of I tell MATLAB to do? And then Alex said, I think it is telling MATLAB to go through the loop for each of 61 players. Yes, so yeah, Alexander, that's correct. So yeah, players of I, this is iterating for each player that we have. So for our first pass, remember pass is going through the loop one time. So for the first pass, that's going to do this for a player of 1. It's going to go for the first player. So in our first pass in our loop, it's going to find indices for pool holes. And then in our second pass, that'll do it for our second player, which is Andrelton Simmons. So it's going to go player by player for each pass that we have, and it's going to do it for all 61 players. Does that make sense, Kevin? Or anyone else? Okay. Okay, so yeah, so we're going just player by player there. Okay, so the next thing that we have to do, we have the indices now for each player, as we just saw. Let's actually do it for one more player too, just to kind of, I don't know, reiterate this. Let's do it for Renhefo, sure. So he's player 41. Okay, so if I go to player indices, that'll be our 41st cell. Okay, so here he is. So his first row, or his first index, that's going to be row 328 in our main spreadsheet. So let's take a look. Let's go to row 328. And there we go. We have Luis Renhefo. So 328, 329, and 330. And that's what we see right here. Those are the first 3 rows for him. Okay, so that's working. Okay, so we have the indices now for each player. Now we want to use those indices to find what I said in the starter code is the event type for each player. So for those indices, I want to look at column 9 and see what the event was. So for Renhefo's first 3 rows that he had, the first one was a single, and then the next 2 were null. So nothing actually happened in play. He didn't strike out. He didn't get a single. Didn't get a double. Nothing happened. So it's probably he just let a pitch go by, or he had a foul ball, something like that. Okay, but we want to use those indices that we found for each player, and we want to apply those indices to find what happened. So I think my use of the word find here kind of threw people off. They thought that they had to use the find command. So I can kind of see, how that would be confusing. But we don't need to use the find command because we already found the indices for each player. So all we have to do now is actually apply those indices. So to do that, we're going to do angels.events, because again, that's the column that we're looking at here. That's column 9. And then we're going to use array addressing. So it's not a cell yet, I know, Ryan, but we're using kind of general array addressing. Actually, we are using cells here, so this will be, I guess, relevant. So we're doing angels.events. And now for our indices, we have player, ind. Okay, so we don't need to use curly braces yet because we're just specifying some index for our main spreadsheet and looking at column 9. So let's actually backtrack just a bit here to kind of hopefully make this a bit clearer. So far all I have here is angels.events and then player index. So all we're doing now is looking at our main spreadsheet, and we're going to be looking at column 9, angels.events, and then we have all of our indices, so we can look at some index or some row in our main spreadsheet. But we're doing this for all 61 players. And our 61 players, we have them stored in a cell array. I don't have it here. Well, I guess I just look at it here for the index. So we have all of our players, all of their indices in a cell array. So we have to apply each respective index for each player in their own cell array. So we have our indices. Again, that's a cell array. So now we have to specify the actual cell. So that's why we're going to use curly braces right now. And I'll do a colon and then a comma I, so we can iterate for each player. Okay, so I'll say it one more time just to hopefully clear things up. I forgot to do these to-dos. I didn't even notice that. So I'm going to do this and then I'll explain this as well. Okay, so we have our indices on line 44 here for each player. And you see that I gave you this part here. I gave you the curly braces, the colon, and then a comma I. So what that did is it basically told MATLAB kind of what size to have. You see here it's underlined red. It's giving us a warning because the size is changing. I didn't pre-allocate the size this time around. I guess I could have and maybe should have. But what this is telling MATLAB right now is that we want to find the indices for the ith player. So in our case, we have 61 players. So we're going to have, in our case, just one row and then I amount of columns. In this case, that's 61 columns or 61 cells. Okay, so we have those indices for each player. And we use those indices to find the event type for each player. So to do that, we did angels.events. We wanted to look at that column. And then we used array addressing to get to that event type. So we have angels.events. And then we have player indices. So that's our cell array here to the left. And then we want to apply those indices for each player that we have. So to apply those indices, we had a cell array here on the left. So we have to use this curly brace kind of notation here for cell arrays. So we apply that for each player. So again, we're looping for I. So that'll go one by one, or that'll go, I guess, player by player for each pass in our loop. And then over here, we have colon and then comma I because we want to find the events for each player in a format that's similar to our indices here. So let's run our code. And once we visualize it, hopefully this will kind of make a bit more sense. Okay, so that ran. And now if I open up player events, you see that the length for each cell here is going to stay the same. So player indices, let's look at the first two. So the first one is 4,514, and the second one is 3,815 for the length. If I click on player events, it stays the same. The length is the same. And that's, of course, because we applied array addressing for our indices that we already found. So now if I click on our first cell here, remember this is for pool holes, we can see each event that he had for the 3 years that we're looking at. So his first one, he grounded out, big surprise. Second one, nothing happened. Third one, grounded out again. Grounded into a double play here on row 8. Really not a surprise. So let's check this. Let's make sure that it's actually working correctly. So let's see when he grounded into a double play. So if we go to the indices for him, see that was the 8th row, right? Yeah, that was the 8th row. So that 8th row is on on row 198 in our spreadsheet. Okay, let's go to our main spreadsheet. We'll go to 198. Here it is. So we have pool holes here, and we see that he grounded into a double play. All right, so everything is working so far. Okay, so any questions so far in the coding? Okay, a lot of time already passed. I didn't even realize that. So we're probably not going to get to our kind of open forum for the project this time around. Okay. All right, so now we want to find the indices where we have a null event. So let's close out of some of these things here. So we want to find the indices for every time when we look at events here when it says null. So we want to find that for each player. And we're going to delete those because these null events, they don't contribute to a plate appearance. Nothing actually happened yet, as a result for that plate appearance. So I guess just some quick background for baseball for no one that really follows baseball. For each time that you go up to bat, you have a plate appearance. So your plate appearance, it needs to end in some result. So you're either going to strike out, or you're going to walk, or you're going to get a hit, or you're going to get out. So you'll see that filled out, that's one plate appearance, something happened there. A strikeout, that was the result for one plate appearance as well. And then null, that nothing really happened there. So, and we can actually see here that that was a ball, and then the next one was a foul ball. So anyways, we want to find every single time when it's not null, and that'll be some plate appearance that occurred. Yeah, I know it's a lot easier to follow when you see someone else doing it. I know it's hard to kind of do it by yourself too. I know that just, I guess, takes time and practice doing things, but I mean, of course you learn the most once you're struggling through stuff. I know obviously it sucks to struggle through something, but that really is when you learn the most. Okay, so we want to find all of those indices when it's null for each player. So to do that, we're going to use string compare once again. So first we need to specify our size here. So that'll be like what we've done so far. That'll be a colon and then a comma I. I often type a 1 accidentally just because an I and a 1 looks similar. And if I did that, then I'd get an error. So always just make sure that you're putting an I. Okay, so we want to find, again, all of those indices for when we have null. So we're going to use find and then string compare once again. And this time around, we're going to look at player events. So we're going to look at the cell array that we just made. So we'll look at player events. And we want to do this for each player. So we're going to iterate on I. So we'll do a colon, comma, I. And then we want to compare our string of null. So we'll type a null, and we'll close it our parentheses. Okay, so we're going to find the indices for each player when it says null. So if I look at player 1 here, we're going to, I guess that's kind of, again, take a step back. So we're doing find string compare player events, and then we have colon, comma, I. So that again, that's going to go player by player. So in our first pass, we're looking at the first player, or the first cell in player events. And then, so Malib will go inside of this cell here, and it's going to look for each time that null shows up. And then it'll give us the index for each time that shows up. So let's run our code. Okay, and then we get our indices, null events. So we'll also show you something here. So we have player events, that is a length of 4,514. Null events, that's a different length now. So this is the length of 3,313. Of course, it's different because our events, they don't always say null. So that's why, they're different. But what this is telling us is that for this first cell array here, null shows up 3,313 times. So our first time that this showed up was in row 2. So let's confirm that. Yeah, that was row 2. The second time was row 4. Yep, that's true. And then, row 5, row 6, row 7, and then row 9. Okay, so again, that's also working so far. So now what we have to do, we have to remove all of the rows when it said null. Again, we're doing that because we want to look at the amount of plate appearances for each player. Okay, so let's remove these null events. Yeah, okay. I was looking at the wrong line. So we want to remove all of those rows from player events. Okay, so we have all the indices, and now we just need to use array addressing and apply it to player events. So I'm going to do player underscore events, and we want to do this for each player, so we're going to iterate on I, and we have to use curly braces since we're looking at a cell array. And then for our array addressing, we're going to use null events, which we just found, null events indices. And then we want to do that for each cell or each player once again. So we're going to do colon, comma, I, and then that'll apply for each player. And then we'll set that equal to empty brackets, which will delete that respective row. So let's go to player events and let's watch this get deleted. So we're looking at Pujols right now. He's the first player. So we're going to see all of these null events go away. So I'm going to run my code, and then we should see those rows disappear. And they do. Okay, so all of those were deleted. So now our length for player events for pool holes, it's much shorter now. Before it was like, what was it, like 4,000 or something? It was around that. And now we deleted each row that had each row that said null. So now our length for pool holes is 1,201. So if we look at this, then we see each plate appearance that he had throughout these 3 years. So we'll see that for each player as well. So let's go to, I don't know, just some random one. And again, we see just each plate appearance. So no row anymore says null since we deleted all of those. All right, so now we're getting somewhere, but now we want to find the amount of plate appearances per player. So we're going to do this because later we're going to remove the players that didn't have more than 500 plate appearances. Okay, so for this, I already gave you our size here. So in this case, I'm doing I amount of rows, so that'll be 61 rows and then one column. And so to find the amount of plate appearances per player, all we have to do is find the length for player events for each cell array here, or each array, sorry. So we can already see this visually. We see that for the first player, for pool holes, he had 1,201 plate appearances. The next player had 1,149, etc. So to actually do this with code, we just need to use our function length. So we'll type in length, and then we'll do player events, and we want to do this for each player. See, I typed in a 1. But we want to do it for each player, so we're going to iterate on I. And there we go. So let's run that. And then we'll get PA, that shows up, that stands for plate appearance. And then we have this for each player now. So remember I said for the first player, you see that length was 1,201. And that's what we see here. Next player, 1,149. That's what we see. Next player, 8. And that's what we see. So all we did was find the length for each array for each player. All right. Any questions on this looping so far?
I have a question.
Okay.
So player events appears 2 times. The first time I include null and the other events, and then the second time there's no events, right?
Yeah, so the first time we used player events on line 47, we used that to actually get the events for each player. So on line 44, we first found the indices for each player. In line 47, when we first had player events, we used those indices that we just found to apply those indices to find the event for each player. And then on line 53, we used array addressing again to remove all of the rows that said null for each player. That makes sense?
Yeah, I see. Thank you.
Okay, yeah. Okay, anything else, guys? Okay. See how much more we have. Okay. I want to make sure we finish this. Okay, so the next thing, and I really probably should have done this earlier in the code, is I had a line here, and I should have had a comment too. That's another thing on your projects. A lot of you had like hardly any comments, so you see here, I have a comment on every single line basically. And really for your project, I would recommend that too. Now, you might not be doing it for every single line. I'm not doing it for all of these 3 lines up here. But you should throw in a lot of comments on your script so it's easier to read it back later on and you can understand what you were doing at each part in the code. So here I should have had a comment myself. So let's say specify target exit velocity. Okay, and again, really, I should have put this earlier in the script. It doesn't matter, but it's just kind of an awkward spot to have this. Okay, so this target EV line of code, that's the target exit velocity that we're going to look at. So for us, we want to see the amount of times that each player hits a ball greater than 100 miles per hour. So that's all we're creating right there. Okay, so now we have to find the amount of times to do that, or that each player did that, so we're going to loop once again. I'm going to comment this out, and then I'll comment these out. Okay, so the first thing that we have to do, we have some comments again here. Well, first we need to specify our length for iterating, so that'll be the same length as before. So I'm using a j for this time for my index variable. It doesn't matter, I could have anything I wanted, but I'm going to do for j equals 1 to length of player, because we want to look at the amount of times each player hit a ball over 100 miles per hour. Okay, so our next part here, we're going to create a cell array that has 2 columns. So we're going to have a cell array, and then within each cell, we're going to have an array where the first column is going to show the player index, so the indices for each player, and the second column is going to be a logical result, so either a 0 or a 1, for if their exit velocity or launch speed was greater than the target exit velocity that we just specified on line 60. Okay, and then later on, we're going to use our logical result to delete the respective rows where a player did not hit a ball over 100 miles per hour. Okay, so the first thing we have to do is specify our size. So we're going to do EV target EV. We'll put a column and then a comma J. So this will just give us results for all 61 players. And then we have brackets here because we're basically creating an array. So we're specifying our brackets just like we do before when we like make an X domain. We do X equals, well, I guess that's actually not a good example, but if we ever make like a matrix, that would be a better example. If we do a matrix A, we do like 303, 201, I don't know, whatever. We have to use brackets when we make that matrix. So that's similar to what we're doing here. We're making a matrix where we have a ton of rows and we have 2 columns here. So that's why we have our brackets. So the first column, as you see in this comment here, is going to be our player index. So we already have all of the indices for each player. So I'm just going to put in player IND, and then we're going to have however many amount of rows for each player. That's why we have a colon. And then we want to do it for J amount of players. And then this last part is going to be our logical result that we're going to put in for if a player hit a ball over 100 miles per hour. And most of you actually got this part right. I know this was a troubling kind of line of code. It was hard to do, but for this last part here, a lot of you got this part right, at least in the end. So let's go here. Let's go through this. Okay, so we have angels.launch speed. So we need to look at that column in our main spreadsheet. Let's take that out. Okay, so let's go to our main spreadsheet. Is that column 54? Yep, so we want to see each time a player has a number here that's greater than 100. All right, and of course for us, we deleted all of these rows that are here not a number or null, but we didn't delete it from the main spreadsheet. We deleted them from our cell arrays that we created. Okay, so we'll do angels.launch speed. And then we're going to use our indices that we found. So we're using array addressing here. So we're going to do player IND to look at the specific rows that we want to look at. Then I'll do a 1. This part, I don't need to put a 1. I think a colon should also work as well. But I only have 1 row for our player indices for that cell array. So I'll do 1. And what I mean by that is this. I only have 1 row here. So I'll do 1 and then a comma J. And then we're going to do greater than target EV. Okay, I'll break this down a bit more now. Okay, we're really running out of time. I don't think this would take as long, but I want to make sure you guys get this, of course. So you should get this first part here. This is just the indices that we already found. And our second part here, we want to find when a player hit a ball that was greater than our target exit velocity of 100 miles per hour. So to do that, we look at our main spreadsheet. So we're looking at angels.launch speed. And then we're going to use array addressing for the indices for each player. So that's this part highlighted here. So we'll do player indices and just regular parentheses. But to look at each player, we're using our indices, which was a cell array. So we have curly brackets here. And we're doing it for each player, so that's why we have a J right here. And then we're looking at this for when that corresponding row or value is greater than target EV, which in this case is 100. So if we run this code, and then we look at our result, come on, there we go. EV, target EV, we have all of our results here. So this is going to show all of the indices. Actually, I guess I could have rewrote this to only look at the rows where we already deleted when it was null, but whatever, it doesn't matter. So we have all of the indices for each player, and then it's going to show whether that specific index, whether the player hit the ball over 100 miles per hour. If they did, then we're going to see a 1. That means true. They did hit it over 100 miles per hour. So now that we have that, all we have to do is delete all of the rows when we have a 0. That means false, they did not hit the ball over 100 miles per hour. So to do that, we need to find those indices. So I'll do false ind, that'll be the indices for when we had a logical false result or a 0. So we're going to do colon comma J because we want to do this for all of our players. And then we'll use our find commands. We'll do find EV, target EV. So we're looking at our cell array that we just created here. And inside of that, we're going to find when that was equal to 0. So we're going to do this for each player. So we're going to do in curly braces because we have cell arrays here. Or I guess we have one cell array, and then in that cell array, we have arrays for each player. So we'll do 1 comma J. And this time, I only want to look at the second row, or the second column, sorry. So that's why I have all of the rows in the second column. We're going to find when that was equal to 0. I'm forgetting a parentheses. There we go. So this is going to look at each array here in our cell array. So it's going to go for J amount of cells. So we're going to start in this first cell here. MATLAB will go into it, and then it'll look at our second column here, and it'll find every single time that this was equal to 0. Okay, come on, there we go. So false index, let's take a look at that. So that this was 0 4,303 times for our first player. And our indices here, we go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever, you get it. Let's take a look at that player. And we see that it was 0 quite a lot until row 31. Let's make sure that that is true. Let's go to false indices here. So I shouldn't see 31 here, and I don't, because 31, that row was true. So row 31, that's when our player did hit the ball over 100 miles per hour. But what we see here for false indices, that's when the player didn't hit the ball over 100 miles per hour. We're going to delete those rows. So that's this line here. So we'll do EV underscore target EV. We're going to do this for each player. And then we're going to use those indices that we just found for when the player did not hit the ball over 100 miles per hour. Okay, so we want to do this for each player once again. And we had a cell array that we just made for those indices, so that's why we're using a cell array kind of index or array addressing here. And we want to delete all of the columns. So for this part here, this is all of our rows, and I want to delete all of the columns, and then I'll set that equal to empty brackets because I want to delete them. Let's run that. Okay, and then if I go to EV target EV, then you'll see here that that is deleted quite a lot of stuff. So here all I have is ones now. So I have the respective index for each player in our main spreadsheet when they hit the ball over 100 miles per hour. So right now I'm looking at our first player. This is for Pujols. So you see the first time that he hit the ball over 100 miles per hour, that was row 425. Let's confirm this. I'll get to your question in a second. So let's go to Angels. We'll go to row 425. 425. So we'll just look at the launch speed here. We see that that was greater than 100. And let's make sure that was Pujols. Go over here. 425, and that's Pujols. So it's looking good. Okay, so 2 questions. Okay, so we got the logical false from the previous line. Yes, we found it in this line here, line 71. And so we found all of those indices when we had a logical false. And then we used those indices on line 74 here to delete those respective rows. Okay. All right. So yeah, Ryan, this is where it went tough for you. So I'll make sure that I explain this then. So we had all of those indices. Question, Ryan?
Sorry, I just want to explain how it went Screwball Jones for me. So when I was trying to delete the logical falses, it's similar syntax to this line based on the deletion and phrase of earlier. However, instead of deleting the values that didn't match up to the target EV, what instead happened was each cell array inside EV target EV had the logical column eliminated completely, and then had the data values transposed within the cell.
Okay. Yeah, I would have to look at your code for that. Okay, so let's. I want to go over this again though, just so everyone understands what we did. So on line 71, we found the indices for when we had a logical false value, and we were looking at column 2 because that had the answer for whether a player did or did not hit a ball over 100 miles per hour. So we found it for every single time that they didn't hit a ball over 100 miles per hour. That's why we have a 0 right here. Okay, so we found all of those indices, and now we applied those indices here to our cell array, EV target EV, and then we used array addressing with those indices we just found to delete all of those rows when a player did not hit a ball over 100 miles per hour. I know that's a lot of things to keep track of, so maybe you might want to look at this part back again. But if you look at each cell array that we have here, if I click on any of these, we're only going to have one. So you did see here we have an empty array here. That's because this player never hit a ball over 100 miles per hour. Let's take a look at who that was. That was Andrew Heaney. Well, he's a pitcher. He hardly ever hits, so that's why. Okay, so again, each player though, or each cell here, should only contain ones, and they do. Okay, so we have all of those indices. Now we can find the amount of times that each player hit a ball over 100 miles per hour. So for that, we just need to use our length command once again. So you can already see the length here for each player. now we just need to write this in code. So we'll do length of EV, target EV, and we got to do this for each player. So for this, I can put a 1, or really that part doesn't matter, but I want to do it for J amount of players. Okay, Kevin, what if you didn't specify the column parts? You only had false, IND, and then... Okay, so you didn't do this. Yeah, that might have been the issue, because we have to make sure that we delete all of the columns, but let me comment this out. I don't even know if this would actually run here. Okay, it did. Go to EV, target EV. Yeah, here we are. Oh yeah, this is when it transposed it, Ryan. Yeah, so we want to make sure that we specify to delete both of those columns. So that's where we put a comma and then a colon. And then that gets to how we want to do it. So yeah, I guess MATLAB didn't like that if you didn't specify that you wanted to delete all of the columns. So yeah, that's why we have the comma and then the colon. So yeah, you have to always make sure that you're explicit for what you want to do. So make sure that you keep track of that part. Okay, so now we have the length or the amount of times that each player hit a ball over 100 miles per hour. Let's go to this though. Here it is. So for our first player, that occurred 211 times. For the second player, it occurred 166 times, and so on. Okay, so now what we're going to do is actually make a table to kind of organize everything for when we actually want to start making our plot here. So the first thing that we're going to do is make a table where we have each unique player that we have. And then in another column, we're going to have the amount of times that they hit the ball over 100 miles per hour. And then in our third column, we're going to have the plate appearances that they had. So let's take a look at this. And that's what we have here. We have each player, how many times they hit the ball over 100 miles per hour, and then their amount of plate appearances. And then all I did in this line is I changed my column names here. I guess I didn't even have to. Looking at this now, it looks fine. But I changed that a bit, I guess. When I'm looking at this now, it seems like I didn't even need this line. Okay, so finding the rate for when each player had a exit velocity of over 100 miles per hour. So now we're just finding basically a percentage for how often a player hits a ball over 100 miles per hour. So for that, again, we're just finding a percentage here. So we're going to do stats underscore t, and then we're going to do, just looking at my code, stats underscore t, we're going to look at our column that's EV, target EVN, so the amount of times that they hit a ball over 100 miles per hour. And then we're going to divide this by the amount of plate appearances. So stats underscore t dot pa. So I'm using array division here because I want to go element by element for this division. Okay, we're not doing matrix division. We're doing element by element division. So I can go row by row. Then we're going to multiply by 100, so we get a percentage. If we run that, then we'll get that. But to save on time here, I'm just going to go to this part where we actually append it to our table. Actually, I can comment all of this out here. So we found the rate for each player. Now we're going to append it to our table as a new column. And then we're going to sort our table by the amount of plate appearances. So we're going to go from highest to lowest. Then we'll find the indices for when we had, when a player had a plate appearance that was less than 500. And if they did, we're going to delete them. So before we do that, let's comment this back out. So let's look at our table here. This will populate again. Okay, there it is. So I only want to look at players that had greater than 500 plate appearances. Maybe I could have changed this a little bit. But there's a lot of players here that have less than 500 plate appearances, and that's not a good sample size for the course of 3 years. So maybe I could have changed it to like 300 or something. But if we have a player that only had 18 at-bats, that sample size is way too small, so I'm not really concerned with looking at them. So what we did is we found all of those indices when a player had less than 500 plate appearances, and if they did, we took them out. Okay, and then the last part, I think I gave you all of this code, was just making the plot. But something that's you want to pay attention to is this, I don't know, all of the formatting or the syntax here for this plot. Because you should use something like this that's similar to this for your project. So one thing is this line here for position. This makes it a lot easier for us if you want to make your plot some specific aspect ratio or size. You can use that function. And then using visible on or off, I really recommend using that too. I won't mark you down if you don't use this, but it'll make grading a lot easier for me, so hopefully you do use that. And then the other thing you want to take note of is that I'm not doing any hard coding in here. And you'll be graded on this in your project. That's one of the kind of aspects that I'm going to grade on. If you're doing hard coding, you're probably going to get docked a few points. So you'll see here in our title, I'm converting a number to a string for our target exit velocity. And then I'm also doing it for the years that we're looking at as well. Okay, so when we did that, we got this plot right here. So we see that Otani hits the ball the most often over 100 miles per hour for the years that we looked at. And I'm going to quickly show you the benefits of not hard coding. All you have to do is change this to maybe, we'll do like 110. This will be really small. Let's run this. And everything is going to update accordingly for our plot. So now we're only looking at players that have hit the ball over 110 miles per hour. At the very end here, for the players that we were looking at, these 3 players, they had 0. They never hit over 110 miles per hour. But everything else, changed automatically for us. So now we see Mike Trout, he hit the ball most often over 110 miles per hour, and that was also updated in our title here. Alright, so in context for your project, you could change, your rolling average or something like that, or the amount of counties to include for a plot. You could just change one line of code and everything would update accordingly. So make sure that you're not hard coding in the project. Okay, so we went over everything that I wanted to for this homework now, so hopefully it makes a bit more sense if you have to look over this video again, after class or later on when you're working on the project. Of course, I recommend you to do that. But yeah, hopefully this helped out. And again, I know we're out of time, but make sure in the Discord, well, one, make sure you're honest, but I want to see how you guys are doing with the project. And if you need any hints, then I'll give you some hints, but it is going to be a challenging project, but I don't want it to also kill you either. So be active in the Discord. So we're out of time. We're going to talk about the project a bit more next class to clear anything up, and we'll kind of have like an open forum where you guys can ask questions too for the project so I can help you out. So I'll see you all on Wednesday. And yeah, make sure you get started on the project. You gotta get going. All right, I'll see you guys then.